14k cubed plus 7k squared minus 70k. And again, we're going to start with our question. First question is there a common factor? So let's look at that problem and see. I think so too. What'll go into 14, 7, and 70? Well, let's think about it. If you take your smallest number, 7, the only factor of 7 besides 1 is 7. So does 7 go into 14? Yeah, it goes twice. Does 7 go into 70? Yeah, it goes 10 times. So we're going to be able to take a 7 out and a k out. That's right. If I take 7k out of 14k cubed, it leaves 2k squared. If I take a 7k out of 7k squared, it leaves k. If I take a 7k out of negative 70k, it leaves negative 10. Alright, and then we got to try to factor this stuff. Now, it doesn't have a 1 on the squared term, so the shortcut's not a possibility here. So we're going to have to do it the long way. So what we're going to do on the next step is we're going to bring our 7k down. We're going to leave 2k squared alone. We're going to leave negative 10 alone. We're going to try to rewrite that k so that we can get 4 terms. 2 times negative 10 is negative 20. The square root of 20 is 4-point stuff. So I ask if 4 goes into 20, and it does 5 times. It's either 4 times negative 5 or negative 4 times 5. And negative 4 plus 5 would give me positive 1. So that's the combination that I need. So I'm going to write negative 4k plus 5k. Four terms now, so we'll do grouping. Okay, so we can't throw this 7k away. It's always going to be part of our answer. Out of 2k squared and minus 4k, we can take out 2k. 2k out of 2k squared leaves k. 2k out of negative 4k leaves negative 2. Out of 5k minus 10, I could take out a 5. 5 out of 5k leaves k. 5 out of negative 10 leaves negative 2. So what have I got now? I've got a 7k, and then because my two parentheses match up, I've got a factor of k minus 2, and then I've also got a factor of 2k plus 5. Moving on, let's tackle 4z squared minus 100. So we should ask if there is a common factor. Again, if you're not sure, take your smallest number, 4, and think about the factors of 4. They are 1, 2, and 4. Obviously, 2 is going to go into 100. To see if 4 goes into 100, we could try and divide, and we get 25, so it does go into 100. You're going to need one of these somewhere. So let's factor a 4 out. So 4 out of 4z squared is going to leave z squared. 4 factored out of 100 is 25. Now let's see if we can factor z squared minus 25. So we count the number of terms. It has 2. And according to our guidelines, if it has 2 terms, the first thing we should check is difference of squares. Let's see if this is the difference of squares. If it's not that, then we'll check to see if it's the sum or difference of cubes. So the first thing I notice is that it is a difference. Subtract. So that's okay. I could take z times z to get z squared. So that's a square. And 5 times 5 give me 25. So that's a square. So it is the difference of squares. So bring the 4 down. So the z squared will go z and z. The 25 will go 5 and 5. And then minus in one and plus in the other. So we got that one factored. Okie dokie. Keeping this train moving. Let's check out 6 plus 3m plus 2p plus mp. There is no common factor in all 4 of those terms. So I'll count the number of terms. I've got 1, 2, 3, 4. And when I have 4 terms, I'm supposed to do grouping. So let's group them. How about 6 and 3m? What can come out of those? 3, okay. 3 out of 6 leaves 2. 3 out of 3m leaves m. Bring the plus down. How about 2p and mp? A p can come out. P out of 2p leaves 2. And p out of mp leaves m. And since my 2 parentheses are the same, then one factor is going to be 2 plus m, and the other one's going to be 3 plus p. So you're sure to see a few factoring by grouping problems on your test. Okay, that leaves us this guy down here, but I'm kind of out of room over here. So I think I'll go back up here and do it. It was 8a cubed minus 27. This is the last type of factoring that we learned. Oops. So we ask if there's a common factor, and there is not a common factor between 8 and 27. The factors of 8 are 1, 2, 4, and 8, and none of those go into 27. So it's got 2 terms. If we have 2 terms, as we said on the problem a couple times ago, we check difference of squares first, and if it's not that, we check sum or difference of cubes. Well, 8 is not a square number, and that's enough to know this is not the difference of 2 squares. So we need to check to see if it's the difference, in this case, of 2 cubes. 8 is the cube number for 2. A is being cubed. Is 27 a cube number? Yes, it is. It goes with 3. Now, if you don't have those memorized, you're going to have to use the cube root function on your calculator. Okay, but I encourage you to memorize the cube numbers all the way through the cube number for 6, and then also the cube number for 10 is 1,000. Okay, well, once you recognize this as the difference of 2 cubes, then what you want to do, or what we did in class, is we wrote it as something cubed and something cubed. That was always our first step. To get 8a cubed, we would cube 2a. To get 27, we would cube 3. And what that allows me to do is it allows me to recognize from these formulas what my a and my b are. My a is the 2a, and my b is the 3. And we keep saying the three other things that we need are a squared, ab, and b squared. Well, those things are not hard to figure out now because we know what a and b are. So if a is 2a, then a squared would be 2a times 2a, which is 4a squared. ab would be 2a times 3, which is 6a. And b squared would be 3 times 3, which is 9. So now if I simply substitute into this bottom formula, because that's the one for minus, that's the one for difference, it says take a minus b to a minus 3 times a squared plus ab plus b squared, or 4a squared plus 6a plus 9. So you're sure to see a sum or difference of cubes problem on your test. The formulas, is it plural for formula? I will give those to you on the test. Now if you take, as I told you, I think in class, if you take my intermediate algebra class, you'll see this again, and I won't give them to you in that class. But in this class, I'll give these two formulas to you. Those are the only two formulas I'm going to give you, but I'll give you those two. Okay, so that's a review of all the different types of problems where the directions are going to say factor. Okay. Oh, what happened there? I didn't mean for that to happen. Okay, so the entire rest of the test, the directions are going to say solve. And you're going to be given equations instead of expressions. So you're going to have equal signs. So part of your test I'm going to give you, and they'll just have problems sitting there like these, and you'll just have to solve. So this first problem that I've got here, 5x plus 2 times 2x plus 3 is equal to 0, that's like the first kind of problem you had in your homework last time. We've got a times b equal to 0. So all we have to do is apply the zero factor property and set each factor equal to 0, and then solve. So if 5x plus 7 is equal to 0, to get the x by itself, I would subtract 7 from both sides first. And 5x would equal negative 7. And divide by 5. That makes one of your solution, x is equal to negative 7/5. And then over here we'll do the similar thing. We'll subtract 3 from both sides. Those cancel. So 2x would equal negative 3. Divide both sides by 2. So my solutions are -7/5 and -3/2. Okay, so you're going to see at least one of those on your test. And then you're going to see certainly at least one of these, which is a quadratic equation we know it's quadratic because it's got the square in it. So remember, if it's a quadratic, we have 3 steps. We got to get it equal to 0 first, then we have to factor, then we have to solve. I would suggest putting those 3 things on your paper to remind you of the 3 things that you have to do on a quadratic. So on this problem, to get the 0, we could subtract 8 and add 2r to the right side. But if I do it on the right side of the equation, I have to do it on the left side of the equation as well. So on the right side, that gets the 8 and the -8 to cancel, the -2r and the 2r to cancel. It gives me 0. On the left side, now I've said this several times now, but I just want to remind you one more time. Remember, when you write your polynomial, put it in descending order, and that'll make it a lot easier to factor. You're going to put the r squared first, the 2r next, and the -8 next. Okay, so step 1's done. We got a 0 on one side. I'm going to keep moving stuff off the screen. Okay, let's move to step 2. Let's go to factor now. So I look for a common factor in r squared plus 2r minus 8. Do I have one? Common factor? I don't think so either. I've got 3 terms, so I'm going to use the AC method. I can use the shortcut if I know the shortcut. If you don't know the shortcut, then just do the regular AC method. But if you know it, you know that the shortcut says that it's going to go r and r. And we got to find 2 factors in -8 that add up to +2. So let's go find those. 1 times -8 is -8. The square root of 8. 2.8 something, so we check 2 and ask if 2 goes into -8, and it does. It goes -4 times. So 2 and -4, or -2 and +4. There you go. That one adds up to +2, so that's the one that we need. So r minus 2 and r plus 4. So the second part of the problem is done. We've got it factored. And now we're ready to solve. And we're going to solve it just like we did the last problem. We're going to take each factor, set it equal to 0, and solve. So r minus 2 equal to 0. R plus 4 equal to 0. Here, if I add 2, get those to cancel. So we have r equal to 2. And over here, I'd subtract 4. Get the 4 and the -4 to cancel, and I get r equal to -4. And we're done with that one. So make sure you know how to solve a quadratic equation. Okay, that takes care of everything from the first page. Oh, crazy thing. Now, let me see what I can do with this second page. Let's get it up here and get it blown up. So the other thing I want you to be able to do on your test is differentiate between a quadratic and a linear equation. So I'm going to ask you, and I've never done this before, 41, but I'm going to do it this time. I'm going to ask you to define them. So I'm going to say define a quadratic equation and a linear equation. So not only am I going to tell you what the question's going to say, I'm also going to tell you what answer I'm looking for. Okay, now, the definition of a quadratic equation in class, when we looked at it, was any equation that can be written in the form ax squared plus bx plus c equals 0. And the definition of a linear equation, way back in chapter 2, was any equation that can be written in the form ax plus b equals 0. The thing that I keep stressing to you in class is that a quadratic is second degree. It's got the x squared, or the y squared, or the z squared. And a linear equation is first degree. It's just got the x, or the y. No x squared, no y squared. That's what I want you to focus on your definition. Okay, so a good answer here would simply be a quadratic equation is second degree a linear equation is first degree. Now, this is college, okay? So you should write sentences. You should capitalize the first letter. You should put a period at the end. That's all I'm looking for. Quadratic equation is second degree. Linear equation is first degree. You give me that, I'll be happy. Okay, but then I'm going to have a couple problems on your test. I can't go down, I got to go up. Probably two, and the directions will say this. Tell whether the equation is linear or quadratic. And solve. Oops, I got it's off the screen a little bit there. Okay, so let's say I give you 36 x squared minus 4. No, that's not what I want. minus 25 is equal to 0. Say that's your problem. Okay. So, is that linear or quadratic? All right, it's quadratic, so just stick your Q out here, and then solve it as a quadratic, which means set it equal to 0, then factor, then solve. Okay, well, it's already got the 0. Let's factor it. If I look for a common factor between 36 and 25, I'm not going to find one. It's got 2 terms, so I should check to see if it's the difference of squares first. Is this the difference of squares?
Yes.
Yes, it is. 36x squared will go 6x and 6x. 25 will go 5 and 5. Minus in one, plus in the other. So we got it factored. And then set each factor equal to 0 and solve. So 6x plus 5 is equal to 0. And 6x minus 5 equals 0. If we subtract 5 over here, I get the 5 and negative 5 to cancel. I'll have 6x equal to negative 5. And if I divide by 6 then, I'll have x equal to negative 5/6. And over here, if I add 5, I'll have 6x equal to 5. And divide by 6. And x will equal positive 5/6. Okay, so if you can recognize that as a linear or quadratic equation and solve a quadratic equation, that's not that big a deal. Okay? Then let's say I gave you same directions. Let's say I gave you this equation. 5y plus 7 is equal to 3y minus 6. So, is that linear or quadratic?
Linear.
That's linear, so just put me an L out there. But then you got to remember how to solve a linear equation, and the strategy there was x's on one side, constants on the other. So it's a different strategy than quadratic. Yeah, let's move the 3y over to get the y's together. So I have 2y plus 7 equal to, and they'll cancel there and get negative 6. So now my y's are on the left. So that means the constants have got to go to the right. So my next move would be subtract 7. So 2y is equal to negative 13. And dividing by 2 gives me y equal to negative 13 halves. Okay, and that'll probably be the last couple of problems on your test. Well, you'll have the define problem, and then you'll have those two problems.
So, it says show an example, right? And let's say we were to do an example and get our own answer wrong.
What I put here? Let me find what I wrote there. Definition and example of quadratic and linear equations solve each type. I guess I just contradicted myself because it doesn't appear that I'm going to ask you for an example. Does that answer your question? Okay. All right. You can see your review assignment starts on page 413. Again, the problems there will be very much like the problems you find on your test.